Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about basic cubic graphs. Our aim here is just to get a feel for roughly what they look like. In the same way, if I told you a linear graph, you might say, I know how that looks, it's a straight line. Or I told you a quadratic graph, you would say that's a curve, either a U-shaped or N-shaped. We want that similar feeling for cubic graphs. So let's get straight into it. Just a little warm-up. I've given you a linear graph here, or a linear equation, and I've given you a quadratic equation here, and by completing the table of values provided, would you just pause the video and double check you could sketch and draw those graphs from the table of values? Pause the video, have a go. Okay, you should have got yourself the following table of values, and the graph should have looked like as follows. Now again, I was drawing out something I said earlier. Because we know this is a linear graph, we knew it was a straight line. Okay, so whenever you see things like that, I need you familiar with the fact that that's a straight line. And if you see something with x squared, you know it's a curve. It's what we call a quadratic curve, and it's even what we call a parabola shape. And because it's positive x squared, it's one of those U-shaped parabolas. Okay, so we already have a familiarity with what they look like. We do know cleverer ways of drawing these using y-intercept and gradient, and we know how to draw these using all sorts of things like completing the square or working out the roots and the x-intercepts, etc. But we originally learnt about them by sketching their graphs from a table of values, and that's how we're going to start to learn about cubic graphs. So straight into an example. If you feel like you can do this, go ahead and do it. Otherwise, I'm going to complete the following table and plot the graph y equals x cubed. Now, cubic are graphs where you see a power of x cubed, okay? The highest power is x cubed. So, all we're going to do is substitute each of these values in here. So we're going to work out negative 3 cubed, which is negative 27, negative 2 cubed, which is negative 8, negative 1 cubed, which is negative 1, 0 cubed, which is 0, 1 cubed, which is 1, 2 cubed, which is 8, and 3 cubed, which is 27. And we're going to plot the x values against the y values. We're going to plot these x values with these y values as a set of coordinates and see what we get. So let's go and have a go at doing that. Negative 3 with negative 27, back 3, down 27, which looks like it's about here. Negative 2, negative 8, back 2, down 8, which looks like it's about here. Negative 1, negative 1, that looks quite easy, it's about here. 0 with 0, 1 with 1, 2 with 8, and 3 with 27, something like that. And we're getting ourselves a curve. So it's certainly a curve, and it's kind of looking like this. If you see, it's going like this, going through 0, 0, and it's shooting off there towards infinity like that. Okay, so that curve there will eventually shoot off towards infinity. It will shoot off towards infinity like this as well, and it's a curve. Alright, so you need to be able to draw a curve like that. Now it says, here's a question that they can ask you having drawn a curve. Use your graph to estimate the value of y when x is 2.5. Well, what we could draw is we could draw the line x is 2.5, see where it intersects our line, and that would be the rough solution, the rough value of y. So the line x is 2.5 looks something like this. There. And there's the line x equals 2.5. And to see, we're asked to find the value of y in our y equals x cubed when x is 2.5. Well, from the graph we can see it looks like it's about 16. So y is about 16 as an approximation. So we can use our graphs for approximations like that. Now if I did type in 2.5 cubed on my calculator, I get 15.6, which means that my graph was a decent approximation. Okay, so that's how you draw them. Let's have a go at another one. Pause the video and have a go at this one. Well, we're going to do the exact same thing. Just be careful here. It's negative x cubed. Okay, so by order of operations, you must cube the number you substitute in first and afterwards multiply that answer by -1. So it's going to be negative 3 all cubed. -3 cubes -27. Multiply it by -1. It's going to be +27. And a similar thing happens in the other ones. Okay, so it would be like this. Now you can see what's kind of happened here. I hope you can see. Here are the x values and here are the y values. 27, 8, 1, 0, -1, -8, -27. It's the opposite order to these, isn't it? Where these started the negative and went up to the positive. So our graph's going to look quite similar, but there's going to be a noticeable difference. So let's just plot these. -3 with 27, so it will be about here. -2 with 8, so it would be out here. -1 with 1 would be here. 0 with 0 would be here. 1 with -1 would be here. 2 with -8 would be here. And 3 with -27 would be there. Let's try and join the dots as best we possibly can. So something like this, and then it's shooting off here towards -infinity. So it looks something like that. Okay, now that was the graph that we've just plotted. Y is -x cubed. It looks an awful lot like y equals x cubed, but it is the reflection of that graph in the y-axis. If you think about it, y equals x cubed looks something like this, didn't it? And you can see that the graphs are similar in their shape, other than one's a reflection of the other in the x-axis here, or the line x is equal to 0. Now we're not done. It did ask us to do a little bit of extra work. It said use your graph to estimate the value of y when x is -2.2. So we're going to draw the line x is -2.2. So we find -2.2 along here. Here's -1, here's -2. Now each one unit has 5 divisions, so 1 divided by 5 is 0.2, so this point here must be -2.2. So we're going to draw a straight line through that point really carefully. Okay, and that there is representing the line x is -2.2. So here we go, this is the line x is -2.2. So if we find where the line x is -2.2 intersects our curve y equals -x cubed, we're going to find an approximate solution. They first meet somewhere here. That looks like, if you read across there, it's about 11ish. It's roughly 11. So y is approximately, we'll use that sign, 11 there. And if you did type in your calculator, if you did work out y equals -2.2 cubed to get the exact answer, and you're allowed to do that with a calculator, you get yourself 10.648, and we got about 11, so we did a decent job. Okay, last one for us to have a go at. Now this one's slightly more complicated. The substitution is quite technical. Pause the video and have a go at filling in the table and then drawing the graph. Now I'm going to go through, but I'm not going to talk throughout. I'm going to go through it super fast. You may want to slow me down if this is too fast for you. So I'm just going to substitute in and work out the answers. Okay, let's plot these pairs of coordinates now as carefully as we can. And let's try and join the dots. I'm going to use a dotted line just to try and help me. Okay, so it looks something like that. And there you go, we have a rough graph from our table of values of y is equal to x cubed, subtract 3x squared, add 1. Now we're not done. It did ask us to do something. It said use your graph to estimate the value of x when y is 0. So let's draw the straight line y is 0. The straight line y is 0 is basically that one there, isn't it? It's just the x-axis. Now where does our graph intersect with that? Well, it seems like it does at several places. One place there, 2 places there, and 3 places there. So it's hard to see with a small axis like that, but that looks like it's about x is about -0.4. it looks like here x is about positive 0.8, and it looks here like x is something like 2.7, that type of thing. Now, I've used my graph to do that approximation for me. I do have a piece of software available to me that will actually work out the correct answer exactly. So I'm just doing that on the side here, and just to double check how close my graph was. The actual answers are x is 2.879 blah 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 blah, so that's not a bad guess. The other one is x is 0.6527. Again, that we're not bad there. And the last one is x is about negative 0.53, etc. And we're not bad there. So we've used our graph to get approximate solutions. Our approximate solutions are x is negative 0.4, x is about 0.8, and x is about 2.7. And we're done. And that's it for this particular video. Thanks for watching.